have reviewed our log functions, we're going to talk about what the graph of the log functions look like. And if you have a graphing calculator, you can have it out here to help you. So basically for our log equation, there's still going to be stuff that could happen out here, but then you're going to have the log portion of your equation with whichever base you have. Then you're going to have all the stuff that's happening in here, and then you can have other stuff being added out here. So just like before, the stuff inside of the equation, so we're going to say inside this set of parentheses here is going to be our horizontal stuff. Okay. And the stuff outside here and here are going to cause our vertical changes for our graph. Okay. So when we look at this, first we just want to understand what the parent function looks like. So the parent function we're going to be graphing, just like with exponentials, is just a log with a base and then x. But this is specifically when the base is bigger than 1, so if it's base 2 or something like that. So what you know that these graphs are going to have is they're going to have a vertical asymptote at 0, and all the graph is going to be on the right side of it. Because remember, we cannot plug in here for x 0 or a negative number. We can't calculate the logarithm of it. So that's why no graph exists on the left side of this vertical asymptote. Instead of the point 0, 1, like our exponential functions, you're going to have the point 1, 0. And the curve is going to climb like so. That's if the base is greater than 1. So notice the asymptote is now vertical, and it's now at x equals 0. When the base is between 0 and 1, so the same type of equation is set up, but this time our base is less than 1, but always positive, so more than 0. We still have our asymptote in the same place, just like how exponential growth and decay shared the same asymptote. And we still have this same reference point. The difference is now that we're going to get a curve that looks more like, oops, not like this. Okay? Sorry about that extra piece. Let me erase it. Okay. So this time our curve will kind of go the other direction. But again, same asymptote and same reference point. Okay? And that's if our base is less than 1. Okay? Just like with the other functions, we need to build the parent function based on our base. So here's an example where our log has a base of 3. So I want to think about what the parent function would look like built with a base of 3. So remember, the things that I do know are that I have this vertical asymptote and this point at 0, 1. Now the rest of the points on the graph depend on the base. Okay? Here the base is 3. Okay? So let's think about some things we could plug in. I would try plugging in 3, and I would try plugging in 1/3. Okay? Based on the fact that the base is 3, and I know that an exponent of 1 would make 3, and an exponent of -1 would make 1/3. So at 1/3, I'm going to have -1. Again, that's because I chose to plug in 1/3. So I'd be asking myself, the log base 3 of 1/3 is what? And it would just be -1. And then I'd plug in 3. When I plug in 3, I'm asking myself log base 3 of 3. So what exponent do I put on 3 to get 3? The answer is 1. So I have that expectation that we saw before for the parent function. But now I have some more specific points. Okay? Now, I'm going to go ahead and do the changes. Notice here there's only one change. The one change in this function is that there's a -1 inside the parentheses. That's a horizontal change. And it's a shift because we're adding and subtracting. And it's going to go to the right one because it says -1. So basically my graph will be complete if I do this one transformation and just shift everything to the right one. Since my asymptote is vertical now, that means shifting left and right changes the place of my asymptote. So my asymptote goes here at 1 now. Okay. This point, the vertex point, that was at 1, 0 is now at 2, 0. Okay. And then I have this point right here. Okay. It's a third away from the asymptote horizontally and down 1, so like here. And I have this point here that's 3 units away from the asymptote and up 1. So it's going to go there. So then I have the shape of my graph. Okay. You can label the points, and we have our asymptote now at x equals 1. Notice that the domain of this graph would be that x has to be greater than 1, but the range would be all real numbers because it continues to go high and low. All right, so in the next graph, the base of our log function is 1/2. So I want to start my graph with that. And again, for the parent function, there's a couple things I know I'm going to have, and then a couple of key points that I'm going to plug in. So the things I know I'm going to have are a vertical asymptote at x equals 0 and this point at 1, 0. The numbers I'm going to choose to plug in here, because the base is 1/2, I'm going to choose exactly that and its reciprocal. Okay? So when I plug in 1/2, I'm asking myself 1/2 to what power would equal 1/2, and that would be 1. So, and I plug in 1/2, I get 1. And when I plug in, I'm asking myself 1/2 to what power would make 2, and that would be -1. So I'm getting this point here, and I get the shape I expected based on when we drew our parent functions before. Okay. Now, there's not really anything going on here inside the function. So I don't have any horizontal changes, but I do have a lot of vertical changes. So you see the negative out in front, okay, here. So I'm going to have a vertical reflection. The second thing that's going to happen is that I have that 2 out in front. So I'm going to have a vertical stretch. And then the last thing that's going to happen is that +4, so I'm going to have to move my whole graph up 4. All right, so the first thing I'm going to do is our vertical reflection. So this point is going to stay on the x-axis, but this point is going to reflect above, and this point is going to reflect below. So now my curve would look like this. So that takes care of the vertical reflection. The next thing I'm going to do is the vertical stretch. Okay? Now, in this case, the asymptote is not laying down horizontally, so we can't really stretch away from it. So we're going to stretch away from this vertex point right here. Okay? So remember, we look at the distance currently of the point, and the distance is 1 vertically between the points. And if we take that and we multiply it by 2, which is the stretch, it's going to move that point so that its total distance is 2. Then we're going to do the same thing for the point below. So that point was 1 unit below the x-axis, but we're going to stretch it so that it's 2. So our new curve is going to go through that same vertex point, but we stretched it out a little bit by changing the other points. And the last thing we're going to do is we're going to move everything up 4. So that does not affect our asymptote in this case, because our asymptote can't really move up and down. It can only really move left and right. But this vertex point that was right here at 0, 1 is now going to move up 4. And this point here was 1 unit away from it to the right, but 2 units above it. And this other point here was just a third of a unit away from, or excuse me, a half of a unit away from the asymptote and 2 units below that other point. So it's going to be here. And then I have what I expect my curve to look like. Okay? So what I want you guys to do is use these 2 examples and try to graph some of the problems that were left for you, so specifically working on homework 6 and homework 7. All right, I'm going to give you guys a couple more examples in addition to this one. All right, so the next example we're looking at has a log with a base of 2. So remember that the first thing we're going to do is we're going to start by drawing the parent graph of just the basic log with a base of 2. And so we're automatically going to put two things on that parent graph. We're going to put this vertical asymptote, and we're going to put this point at 1, 0. Now the other points surrounding that depend on this base, and I'm going to choose that base and its reciprocal to plug into my function. So when I plug in the base itself, log base 2 of 2 is 1. So I plugged in 2, and I got 1. And when I plug in 1/2, log base 2 of 1/2 would be -1. And so that's going to give me this parent function. Now notice in this graph, there's only one vertical change, the -3. Most of the stuff is happening horizontally. And I'm going to factor out that -2 that's in the parentheses. Oops, I made a big mistake. I'm going to factor out the -2 that was in the parentheses. So what I see here is a horizontal reflection because of the negative in the parentheses. I see a shift to the right, or sorry, let me do my compression first. I see a horizontal compression because of the 2 that's multiplying in the parentheses. And then the -2 in the parentheses is going to cause a shift right 2. And then the last thing I'm going to do is move my whole graph down 3. So horizontal reflection is going to take and shift everything over the x-axis. So all these points are going to move onto the other side, as we see here. Then for the horizontal compression, this means things are moving back towards the asymptote, okay? So times 1/2. So this point right here was 2 units away from the asymptote horizontally. We're going to take that 2 units, multiply it times 1/2, and move that point so it's only 1 unit away from the asymptote, so here. So this point that was 1 unit away will now only be 1/2 a unit away, and this point that was 1/2 a unit away is now only going to be 1/4 of a unit away. So there is our new curve, horizontally compressed back towards the asymptote. Then we're going to shift everything to the right too. So I'm going to go ahead and make that on the new graph. That's going to put our asymptote here to the right too. The point on the axis is 1/2 a unit away. Point 1 above it is 1 unit away. And then there's this point that's just 1/4 of a unit away. And I'm going to make that curve, so that's everything shifted to the right too. And then the very last thing I'm going to do is shift everything down 3. So all of these points are just moving down 3. So you get this curve here. And your asymptote is here at x equals 2. All right, so these are the examples. Now I'll say what I had said before. These are the examples that I want you guys to use to be able to try and start some of the homework. Go through the steps we did each time, draw the parent function, list the transformations, and then try to do each one. So I want you to try to do the homework first so we can spend time answering good questions that you guys have. So there have been copies left for you to start the homework that is on this. Thank you. See you guys tomorrow.